So I'm Michael. I'm a product manager at our agent platform team. And I have Ahmad, who is my colleague at Google Cloud, join me, and Minzu from Klook, who is the director of engineering. And today, we will talk about how to build connected AI at scale. We will walk you through what are the common goals, the challenges that we see customers face. And then we will talk through how Agent Platform can help you solve some of these challenges. We will look at Agent Registry, Agent Identity, SpecBoost, and Google ADK. And then we will have Min come up and show us how they apply the Agent Platform in the real world to solve real-world problems at Klook. Now, last year at Next, it was all about building agents that can do things, that are connected. MCP was still relatively new. People were really excited about it, connecting to data sources, to APIs. And A2A, the agent-to-agent protocol, was actually announced here last year. So happy birthday. But nowadays, the challenge has really shifted, right? It's no longer about building an agent that can do stuff. The challenge is now how to do it at scale, because organizations have hundreds of agents that do things. And oftentimes, it's that there is actually multiple agents that do the same thing. And there is multiple MCP servers and tools that do the same thing, right? Because people were just so excited about building, and there were not really tools or processes to sort of manage that sprawl. So today, we will talk a little bit about how Agent Platform can help with that. But before going there, the specific challenges that we see are for builders. Discoverability, how they can discover what MCPs, what agents they already have in their organizations that either they themselves or others in their organization build. How, if they discover it, how can they easily build on top of those, right? And that includes things like ADK, but also Gemini CLI or Agent Designer, right? And how to do all of this while maintaining security posture, right? So how do you make sure that only the right people and the right agents have access to the right set of tools? And for platform teams, right, it's all about how do you make sure that you have a well-lit path for your teams to use a specific MCP server without causing confusion of having 17 servers to talk to BigQuery, right? And you also want to have visibility and control to all the agents and tools that are on your platform. So let's see how building with Agents Platform can help. The specific components, you have seen, I'm sure, over the week that there is a lot to Agent Platform. So we are going to just focus on a specific few things there. We're going to talk about Agent Registry as the single source of truth for agents, MCPs, and models. We're going to talk about orchestration with Google ADK as a layer that can help you orchestrate between the MCPs and the ADK and the sub-agents, right? And then we will see how agent identity and authentication configurations help us to build this system at a scale and securely. So first, let's talk about Agent Registry. Agent Registry is the single source of truth for all your agents, all your BigQuery MCP, sorry, not BigQuery, just all the MCP servers that you have in your organizations. There is an easy path to register third-party MCP servers if you, don't find one already that exists by someone else added to the registry. And it's available as a portal like this. I will show it later in a live demo, or via API or an SDK to call. Agent Registry has built-in support in ADK. So ADK is an open source framework for building agents. And we made it really easy, just a few lines of code, as you can see there, to just invoke an agent or an MCP server that is registered in the MCP registry. Now, an important aspect of building these systems securely is agent identity. Agent identity is a SPIFFE-based standard that ensures that every agent has a specific identity, as you can see there. This is a SPIFFE ID. And what it allows you to do is that identity is actually tied specifically to the lifecycle of the agent. So it gets created when you deploy a new agent, it gets assigned. And then when you delete that agent, this identity is removed, and all the permissions are also removed. So there's no rogue permissions in your system. And this really improves on the previous system where by default, a service account was shared by all agents in your project, right? And so it was very hard to maintain granular level permissions. And agent identity also comes with a secure credentials vault. And it seems like the GIF is not loading well, so sorry about it. But the secure credentials vault is a system for securing a third-party system credentials. So you can store API keys or OAuth 2.0 credentials to access the third-party systems. And this allows the developer to focus on building the agents instead of making sure that their secrets are implemented as expected and not leaking into the internet. So this all sounds great, right? And it sounds like a great foundation. But what if you don't have the tools to start building with? I'm going to hand it over to Mike to talk us through how to create our own MCP servers.
Thanks, Mike. Hey, everyone. My name is Mac, product manager on the same team. It's Michael. So Mike posed a good question, like, what do we do if you don't have MCP servers? But I want to take a step back and, like, what do you do if you don't have proper API specs, or you don't even have API specs, right? Or your specs are outdated or non-descriptive enough. So let's be honest about the reality of enterprise day 2. You built an agent, and now you need your agent to access your organization's most critical data. So the problem is that data usually lives in various different systems, internal systems, and some legacy systems, perhaps. And in fact, we see a lot of customers that have a lot of enterprise APIs that aren't agent ready. So they lack rich, accurate OpenAI specifications that LLMs require to understand how to interact with them. So when an agent tries to call your APIs, they will start hallucinating or not try to understand, like, the call could fail. You can't run a governed enterprise scale AI product if you have to spend a lot of time trying to update your documentation. And I started my career as a software engineer as well, so I understand, like, documenting is not like the P0 in coding, right? It sometimes becomes an afterthought. So we want to build a solution around that. So this is exactly why we built SpecBoost. So with SpecBoost, you can do many things. But to begin with, let's say you don't have any specifications. So what we can do is we can go to logs, and based on your API logs, we can actually generate API specs from scratch. Let's say you have API specs. We can take those API specs and optimize it. So not only are they more human readable, they're actually more agent readable as well. This technology came directly from DeepMind. It's using Gemini in the back end. It's agent-based itself. And so we are excited to integrate, like, DeepMind's functionality into the product as well. In the next slide, I'll show like a quick demo here, but everything starts in API Hub. You enable SpecBoost, and from there you can do some configurations. But one main thing I want to emphasize here, the future vision is that an engineer should not need to go worry about API specs. Like, did I add too many, enough comments? Is there enough, like, error examples so the agent knows what to do? The future of the documentation should be it gets live updated as you update your APIs. So that's where we're headed with this. A single place where all your API specs live, it's agent readable and always automatically up to date. All right, let's walk through here. So here we have the API Hub. We turn on SpecBoost. You can actually just boost your specs. That means you have API specs. You can actually generate specs. When you generate specs, you can go to the API Gateway, Apogee Gateway runtime. You can get it from Shadow API Discovery, or you can go to any GCS bucket and get it from any logs. Once you do that, you press save here. It starts the process of going through your logs and whatever not that you picked. And then as traffic flows, we observe the shape of your APIs producing the spec. We also pick like a window of time that you want the specs generated, so we can consolidate everything in one place. And nothing gets published without human sign-off. So there's a few things that could happen when AI is going through your logs. It might actually find an API spec that you already have, in which case you want to be able to do a merge or compare to what's in your documentation versus what's live in production. This is when engineers deploy APIs without updating the docs. Right? So you'll have an opportunity to do a diff, and from there you can actually merge your API specs, so you can actually have it up to date. All right, so now that we have API specs that are human readable, we can now discuss MCP, right? So, I want to explain here. So what we're building here is that within API Hub, you have your API specs in there, and from there, we are working on having a one-click conversion to an MCP service. So this is the enterprise day 2 differentiator. So we haven't just hacked together a single connection. We've taken the customer API, generated a rich spec, wrapped in a secure protocol, and published in a governed registry. Everything in API Hub that's synchronized to what Michael was talking about, the agent registry, so it's always in sync. And now any authorized agent builder in the company can discover and reuse this tool safely. So we went from no specs to rich specs to an MCP service, back to the agent registry, so it's discoverable by other agents. I'm going to hand it back to Michael to show us a demo of all of this in action.
So let's switch to the laptop for a demo. And I'm going to start here. So this is my project in GCP. You can see the new agent platform UI. So here in this platform, I have everything that I need to build, scale, and govern and optimize my agents. So in this case, I'm going to focus on the agent registry, since that's what we were talking about. So here in agent registry, I can see all the agents that I have in my organizations in this project across various locations. Now, let's introduce a use case, right? So Min later is going to talk about how Klook is using agent platform to build these multi-agent systems. I have built myself a very primitive version of a travel advisor or activity advisor. I'm going to say that I want to build an agent that finds me what to do based on activities, based on city, and based on the time and the weather, right? But before I get started and start thinking about, OK, how do I build an MCP server that gives me weather, or how to get a bunch of activities, I can go to the registry and just search for a weather-related assets. And I can actually see that there is a weather agent and there is a weather MCP. So I'm curious about the agent, so I'm going to click on the agent and see if this is something that could actually solve the problems that I have. Here you can see the details of the agent, including the skills that the agent has. So you can see that this agent actually helps me get weather, and it helps me get current time for specific locations. That's pretty aligned with what I want. And it even gives me here a simple code snippet in ADK to know how do I integrate with this agent from my ADK running code. Now, one more thing about the agent identity, right? So I talked about how each agent has their own identity so that you can assign permissions and secrets from the vault just to this agent. If I go to the detail of the identity, what I can actually see here is more details. So what I see here is a set of auth providers. And so what an auth provider is, you can see I already have one set up because this is a running agent in production. It's a set of credentials that I can create for my agent. And what it supports is auth, both two-legged and three-legged. Three-legged is when you want to have the agent act on behalf of the end user, so that I actually would sign in, and let's say I only want to see data that is related to my account. That's what I would use. In this case, I just use the simple API key because it's a generic server. Now, we talked about Agent Registry as well in the context of MCP servers. So what I can see here, I can actually go to the MCPs, and I know back to my use case that my agent should also suggest some activities. One of my teams have built a BigQuery data set that helps store activities about various places. So I'm just actually going to see and search if there is a BigQuery MCP. And I don't even have to use the search because I see it right here. And again, I get an easy code snippet on how to integrate with this MCP server directly from my ADK. You can see it includes like the specific MCP server name and ID that I would be using here. It also includes, this Agent Registry UI also includes the details of what tools I have. So now let's switch to the code. And let's see how this actually works in practice, right? So I have here my agent built in ADK. And what I did here is I first initiate the agent registry, right? So I provide the project ID and the location of where this should be connected to. I define the remote weather agent, right? So I'm using the remote weather agent, which you can see here. I just provide the ID that I get from the registry. And then I define the BigQuery MCP server, similarly just passing the variables of this. Then in my agent itself, I have a bunch of instructions, and I provide the tools and the sub-agents for this agent to use in the real world. Now, let's see how this agent actually can help me. And this is, I'm going to dare a little bit because we have some networking issue. So I need to turn on my Wi-Fi and hope that the SSH tunnel to my remote machine works. So let's give it a try. I'm going to switch here. If it doesn't, then the code is all we get. All right. Let's see. OK. So it seems like it's not collaborating with us today, but because of this networking issue. But anyway, let's go back to the presentation, and I will have Min show us more about how Klook is using the agent platform.
Thanks, Michael. My name is Zhu Min, and I am a director of engineering from Klook. Klook has been a long time partner with Google Cloud. When Google launched ADK, last year we were one of the first adopters. Recently, we built a supply research agent with ADK and Agent Registry. In this part, I'm going to share the challenges we faced and how we tackle them while building this agent. This agent actually is for our business development team to help them to discover high-value travel product supply opportunities. OK, a quick intro. Klook is the largest online platform for experiences in APAC. We have like more than 300,000 products across 4,000 destinations in 2025. We had over 65 million experiences booked. For any OTA platform, the competitiveness comes from many angles, like booking experience, pricing, marketing, but supply quality is definitely a critical one, especially for the experience products, which are incredibly diverse. So we are deeply committed in providing the high-value, inspiring, and unforgettable products to our customers, like ice fishing in Hokkaido, where you catch a fish and eat it as tempura afterwards, or rowing through the stunning coastal landscape in Ninh Binh of Vietnam. They are the kind of experience that you would probably tell your friend about at dinner, and probably more than once. So who find all these amazing products? Our BD team. They wear a lot of hats, like many other companies, but it all starts with the supply research, which is the source of everything downstream. So this is like what their supply research process used to look like roughly. The team started with putting all kinds of data from external social networking platforms, from internal product catalog, reviews, and market insight from competitors. Then data processing, heavy manual work that requires domain knowledge and experience. Then step 3, turn all of that into an acquisition plan, then look back and start over again. As you could tell, the problems are quite obvious. First, supply lags behind the trend because lots of manual work. So by the time we finish analyzing, filtering all of the data, the trend might already be cooling off. For seasonal products, think of cherry blossom, tours, or Christmas market, that lag is a killer. Second, it doesn't scale. The team can't cover the mid-long tail, and that's a huge pool of opportunities. Third, the insights are deeply buried. So valuable signals are scattered across multiple platforms, and connecting dots takes serious effort and experience, which is very, very difficult. Okay, solution. This is actually a classic case of turning a multi-step business workflow into an agentic solution. We started with the supply trend part, which is about figuring out the unmatched needs in the market. We built a supply trend analysis agent that coordinates with multiple specialized agents. Each focuses on analyzing one specific social networking platform. Standalone agents instead of skills that plugged into the parent agent, as they each need their own separate context and they need to run in parallel. We adopted an orchestrator sub-agent pattern. In our test, this also works better for the models that tend to have the context anxiety. 3 key learnings here. First, speed. With ADK spinning up new agents and wiring them together is best. If we don't need to customize the behavior of the agent that much, like via callbacks, we can simply wrap up everything like instructions, resources, and tools into one simple skill. Second, reusability. Every agent goes into the agent registry, so they can be discovered and reused actually beyond the supply research. The same YouTube analysis agent, for example, may also work great for voice of customer analysis. Third, continuous optimization. We publish all of these agents in German enterprise. So our non-technical domain experts across the organization can directly access these agents, play with them, feedback, and help us improve. Then we build another in-house supply agent. It evaluates our own supply quality with internal booking data, product catalog, reviews to check if it matches the need in the market. There is an important enterprise architecture decision. How do you securely open up your internal data, your APIs, to LLMs? MCPs, function calling, or CLI-based approaches, regardless of which you choose, the fundamental challenge is the same. Like many organizations, we are also in a transition. As you can see here, we have a mix of MCP servers and direct API calls. But the direction is converting the APIs into MCPs and centralize them into the agent registry for not just the better LM performance, better discoverability, but more importantly for governance. As an organization, we want to know what tools an agent can access. And we want to be able to centrally manage that access to review, to monitor traffic and audit. Finally, orchestration. Wiring everything together, we applied a multi-layer orchestrator sub-agent pattern. A lead research agent sits on top. It manages the supply trend analysis agent, the in-house supply analysis agent we just talked, and a competitive intelligence agent. The lead agent plans, dedicates, monitors, and adjusts like a project manager. All of the results then goes into the research report agent to generate one final consolidated report. The team can define or adjust the output format with the formatting skills. So to make sure that everything is autonomous. If you remember the process I showed earlier, getting the report is not the end. The true value actually comes after. New supply acquisition or existing supply quality improvement. Those downstream workflows can also be reshaped with AI, and we are looking into that. All right, to wrap up, we built a group of agents. Actually, there's quite many of them. Dedicated agents for dedicated tasks. If they have their own separate context and need to run in parallel. ADK makes building and orchestrating the agents fast. And Agent Registry makes them reusable. We also adopted MCP gateway for discoverability and governance. Overall, the new solution solves the time lag issue. It's highly scalable and can surface insights that used to be ignored by BDs. As a result, yeah, we do get quite positive feedback from the team. Days of work can now be solved in hours, and they can focus more on high-value tasks such as negotiating with merchants. All right, that's the end of my sharing. Yeah, back to you, Michael. Yeah. Yeah.
All right, thanks. So just to recap what we saw. Admins can govern their agents, their MCPs with Agent Registry. They can securely make sure that whoever should have access to the credentials for those third-party services has, and who shouldn't does not. We saw how builders can create stuff without friction. They're using ADK and using the built-in primitives to support Agent Registry. And we saw how everything has been battle tested with Klook and others in the real world. So that concludes our session here today, and I think we have a few minutes for a Q&A session if anybody has questions. Thank you.